So, what if I told you that there's this hidden science, a secret link, really, connecting the most boring, everyday stuff in your house to the absolute cutting edge of technology? Well, today, we're going to pull back the curtain on it.
I know, it sounds like a riddle, right? I mean, what on earth could your laundry have in common with life-saving medical research? The answer? Well, it's definitely not what you're thinking.
It's all about this invisible force, a fundamental principle of physics that's quietly shaping our world in ways you'd never expect. And to really get our heads around it, we've got to start somewhere super familiar.
Yep, you guessed it, we're starting in the laundry room, with probably one of the most common workhorse appliances in any home.
Okay, so almost all of us have one of these, right? Something like 87% of households in the US, and most of them are those classic top loaders. They are just total workhorses, right up until the moment they just stop working.
So let's play this out. You've got a full load, you press start, and crickets. Nothing happens. Or, maybe what's worse, it starts filling up with water and it just doesn't stop.
Now, a lot of the time, the problem isn't some crazy computer meltdown. Nope. It's often this one single, really simple part, the water inlet valve. Think of it as the bouncer, the gatekeeper for all the hot and cold water coming in.
And believe it or not, this simple little valve is way more important than you think. It's our doorway to a much, much bigger idea.
Okay, so replacing this thing, it's actually a pretty simple DIY job, but don't let that fool you. Because at its very core, what is this valve? It's just a switch, an on-off switch for water. And that simple idea, just controlling the flow, it's incredibly powerful.
So this on-off switch is just step one. Now, I want you to imagine something. What if you could control flow that simply, but with zero moving parts? None. That's where we're headed. We're leaving basic plumbing behind and diving into a field of science that can actually do complex calculations using nothing but liquid.
This amazing field is called fluidics. And the concept is actually pretty simple. You're just using a fluid, could be air, could be water, to do stuff, to perform operations. It's literally like teaching a stream of water how to think. You're creating the basic building blocks of a computer, but instead of using electricity, you're using jets of fluid. How cool is that? And the key to all of this is something called a fluidic amplifier. Okay, so in electronics, you know how a transistor uses a tiny bit of electricity to control a huge flow of it? Well, a fluidic amplifier does the exact same thing, just with fluid. A tiny, weak jet of air can precisely steer a much more powerful one. And just like that, you've got a switch or an amplifier with absolutely no moving parts to break or wear out. It's brilliant. Okay, this is where it gets really interesting. We see how this simple principle can scale up to some absolutely mind-blowing complexity. So let's head back to that medical research lab we mentioned earlier. All right, this machine is called a flow cytometer, and it is an absolutely critical tool in things like cancer research and developing new medicines. I mean, look at it. On the outside, it's this sleek, almost futuristic-looking box. But pop the hood on this thing, and on the inside, whoa. It is just an impossibly intricate maze of tubes and sensors and lasers. And this is where the magic happens. All of that mind-boggling complexity, it's all engineered to do one single thing with just breathtaking precision. And that one thing is manage the flow of liquid.
So, what does this thing actually do? Well, think of it like the most advanced sorting machine you could possibly imagine, but it operates on a microscopic cellular level. Here's the rundown. It uses this special sheath fluid to funnel cells so they're forced into a perfect single-file line. Then, as each individual cell zips by, lasers zap it, and the machine instantly reads the signals and sorts it. This happens thousands of times a second, and the whole thing is only possible because of that hyper-precise control of fluid flow. It is pure fluidics in action. So the big takeaway here is that fluidics gives you this unbelievably precise control. Now let's take that same exact idea and scale it way, way up, from the microscopic world of cells to the wide open sky. Yeah, you're seeing that right. These are the promises of applying fluidics to aviation. We're talking about aircraft that are lighter, cheaper to build, way more agile, and a whole lot stealthier.
And this really gets to the heart of it. A normal plane uses all these heavy, complicated moving parts, right? Flaps, ailerons, rudders. But a fluidic aircraft, it just gets rid of them.
It replaces them with tiny jets of air using a technique called active flow control. It's just like that fluidic amplifier we talked about. You use a small, targeted puff of air to control a much bigger flow, in this case, the massive flow of air rushing over the entire wing.
And get this isn't just some sci-fi dream. This is really happening. Back in 2010, BA Systems flew the Demon Drome, one of the very first planes without flaps. Then in 2017, they tested another one called Magma. And right now, as we speak, DARPA is building the X-65. It's an experimental plane designed from the ground up with active flow control, and it's scheduled to fly in 2025.
Okay, so let's tie all of this together, from a broken washing machine all the way to the future of aviation. We've been following this one single powerful idea the whole time. Think about it. You've got the washing machine's valve controlling water flow. You have the flow cytometer precisely guiding single cells past a laser. And you have an advanced aircraft wing shaping the flow of air. They seem totally unrelated, but the principle is exactly the same. It's all about the elegant, powerful, and usually hidden science of controlling flow. It really just goes to show you, doesn't it? The most extraordinary, futuristic technologies can have their roots in the most mundane, ordinary objects. And that leaves us with one last question to chew on. What other amazing, profound sciences are hiding in plain sight, maybe waiting to be discovered, right there in your own home?